Hello everyone. Today we are going to solve some remaining problems for this unit. So before wasting any time, let's solve question number 21. So a variation time t with velocity v of two cars p and q is shown in figure 2.3. Here, graph shows velocity versus time graph. In this graph, we have a velocity versus time graph of q and car p. So question A is the speed limit for cars on the road is 100 km per hour. State and explain whether car Q exceeds the speed limit. So you have to check whether the car Q is exceeding the speed of the limit or not. For that, we have to calculate the what is the speed of the car. For that, first we have to convert kilometer per hour in meter per second because in this graph we have velocity in meter per second. So first we did the what is the speed limit in meter per second. So it is going to be at 27.8 meter per second. Now at 12th second, here you can see the graph shows car Q reaches maximum velocity. Here the velocity will be maximum of car Q is about 12 seconds and it is a 30 meter per second. So the limit, you can say speed limit is 27.8 meter per second, but car Q is going with the speed of 30 meter per second. Hence, you can say that car Q exceeds the speed limit because this. Okay, I hope you understand question number one. Question number B says calculate the acceleration of P. Now, you know the what is the how we find the acceleration from the graph of velocity versus time graph. So we have to just do like this means slope. You have to if you find the slope of this line of car P, you can easily get the acceleration over here. So the solution is like initial velocity is 20 meter per second, final velocity will be 24 meter per second. Now it is at the t is equal to 0 second, and the last one 24 is about at 12 second. So here you can see here the t is equal to 0. It is about 20 meter per second, and at 12 second the car is speed over here, and from this graph you can easily say it is attain some speed of 24 meter per second. So you know the definition of acceleration, final minus initial velocity upon taking time. So 24 minus 20 upon 12, and it is about 0.33 meter per second square. And here, the value of positive means it is accelerating with the time. So, into question number C, determine the distance between two cars at time t is equal to 12 seconds. So we need to find what is the distance between these two cars at 12 seconds. So you know the what is the velocity over here, and then you can make a difference. Okay, by this. So if you want to find distance from a velocity versus time graph, in our previous video, I told you that you need to find a area under the curve. That means if you need to find what is the displacement of car Q, so you have to just measure the what is the area under this of this line. And if you want to know that what is the displacement or distance covered by the car P, and you need to calculate what is the area over here. Okay, so for car P, I want to say that it is like a trapezoidal shape. If you know the what is trapezoidal, it is a shaping like this. And let's suppose this is the A, this is the B, and height of the trapezoidal is h. So the area of this trapezoidal we can calculate like this A plus B into height. So here 1 by 2 u plus v into t. So put the values over here. What is u and 12? And you got the answer 264 meter. But in the case of car Q, it is you can say it is triangle. And what is the area for the triangle? It is 1 by 2 base into height. Okay. So 1 by 2, what is the base over here? 12 second and height which is 30. So base into height, 1 by 2, 12, 30, and which is 180 meter. So you need to find what is the difference over here. So it is about the separation between cars at the 12th second. It is 84 meter. Now we move forward in question number D. From time 12 second, the velocity of each car remains constant as its value at 12 seconds. So it means after the 12 second, velocity will be constant. Okay. Determine the time t at which car Q passes car P. Okay. So for that, at the 12 second, car Q is at 84 meter behind the car P. Here you can clearly see the difference. So constant velocity for 12 second, okay, we know, which is also given in the question, okay. So VP 24 meter per second and VP is 30 meter per second. From this, you can say after some time, Q car is going to speed passes through the car P. Okay. So in order to find what is time, you need to find relative velocity. Okay. So relative velocity of Q car with respect to P. So it is right like this VQ minus VP. It's about 6 meter per second. So after 1 second, that means after 1 second, the difference is going to be decreasing by 6. Okay. That means, let's suppose in 1 second, it is uh, car Q exceeds the near to the car P because its speed is greater than P. So once for 1 second, it is going to decreasing the 6 meter, the distance between two cars. So in which second we are going to recover 84 meter because the distance between two car is 84 meter. So we need to cover 84 meter to passes the car P. Okay. For 1 second, it is going to be take 6 meter. So now it is 14 second. So it is the 14 second, but we take here initial time is 12 second. So we have to just add 14 second. After the 26th second, the car Q is passes the car P. Okay. I hope you get the question number B. So this is the question number 21. 22 says A, define speed and velocity and use these definitions to explain why one of the quantities is a scalar and other is vector. We have done this question in our previous video, so we didn't, you can take as a homework, okay? So in question B, a ball is released from the race and falls vertically. The ball hits the ground and rebounds vertically, as shown in figure 2.31. Here, they show a ball is going to downward and hit the surface ground, and it is rebounding on the vertical direction, not on any direction. Okay. So the variation with the time t of velocity, okay, of the ball is shown in figure 2.32. Okay. They show how the velocity is changing with the time. You have to ignore that the what is here air resistance. So in first, without calculation, use this figure to describe the variation with the time t of the velocity of the ball from t is equal to 0 to 2.1 second. So you have to just need to understand or illustrate this graph, what is going on here. So it is 0 to 2.1 second. Okay. From this to this. First, it goes the maximum value of the velocity. Okay. When initial ball is at rest, this speed is 0. Okay. Then it will go to the ground due to g. The increase in velocity is due to g, means it has experienced some acceleration. So at the moment the it ball is hit the ground, it has a maximum velocity, I would say. It is about 10 to 11 something. And after hitting the ground, it will changes the direction. You can see here, this is the direction before the hitting the ground. After the hitting ground, it changes the velocity or direction of velocity completely pi degree, or I would say 180-degree shifted. So velocity is a vector quantity. So you have to clearly say, consider the velocity as well. So it is at the same second, uh, it contains some same value, but not the same value because it may some loss of the energy in either sound energy or the energy we cannot take it. Okay, so it loses some speed, but at the same time they reverse the direction. So this few more seconds, few microseconds, I would say, it completely changes its direction. Then it is going to be zero. Okay, and then it will come to reach that point. It is not always it is going to like this, because it every hit the ground, every time it's hit the ground, it will release the energy, and after eventually it is going to be stopped. So here I write all these things. Okay, you can post the video, and if you want to read it. Okay, so in the second question, calculate the acceleration of the ball after its bounce from the ground. So you're working. So at the point one, let's suppose T1 V1 is equal to 1.1 second and minus 8.8 meter per second from the graph. Okay, and T2 V2 take this value. Okay, now we know the definition of acceleration is V2 minus V1, T2 minus T1, and it's like this. And this you may here find the acceleration, and in the first time I consider the G. Okay, it is similar value about the G. Okay, and it is downwards. So here the acceleration works over here is the gravity. Okay. Now question number three is calculate for the wall from a t is equal to 0 to 2.1 second, the distance moved and the displacement from the initial position. So as we know, how we find the displacement from the VT graph, the area we did on question number one as well. So we have to do for the 0 to 2.1 second. Okay. So first you need to calculate this area, then this, and then from the 2.1. Okay. So first 1 by 2, 1.1 into 10.8. Here they are in triangle shape. So you have to just apply the formula 1 by 2 base into height. Okay. This is A1. This is area under A2, 3.96 meter. And the last one, 2 to 2.1 second, the area is about like this. Here, they ask for the distance and displacement. So for the distance, we have to just add all the values. Okay. But in the case of displacement, it is vector quantity. So you have to consider the value and direction as well. So here it is on the positive side, and second A2 is on the negative side. So you should consider the direction as well when you come to calculate the displacement. So here, why I here the negative? I hope you clear the concept, and it will 2.03 meter downwards. Okay. Now this is about question number three. In question number four says on a copy of figure 2.33 here, sketch the variation of t with the speed of the ball. Okay. Here they given us velocity versus time graph, and we have to draw speed versus time graph. So how we draw this graph? You can draw, if you draw this same figure here, it will not work out because the velocity is a vector quantity and the speed is not. So for speed, it should be have some positive values, not the negative one. Okay, so it will be not useful area for you if you want to plot speed versus time graph. Okay, here I draw a graph. Here you can see there is no negative values over here because it is a speed versus time graph. I hope you keep in mind this. Okay, so this is variation of speed. You can do at your home. Okay, on the graph paper to be precise. So it is all about question number 22. Number 23 says a car is mass of 1500 kilogram travels along a straight horizontal road. So it is a car over here. It is going to the horizontal road, okay, straight. The variation with the time displacement of x, this car is shown figure. So it's here they given us a displacement versus time graph, okay. So they ask us in the figure 2.34 to describe qualitatively the velocity of the car during the first 6 seconds of the motion shown. Give reasons for your answer. So they given us displacement versus time graph, and they ask about what is the qualitative velocity of car. Okay, you know how we find the velocity from this graph, which is dx upon dt. Either you can say slope of the graph. So I hope you can see clearly see the for this second the graph is going to like straightforward. That means velocity is constant throughout this about 3 seconds, I would say. And then it is bent like this. And you can see here the band curve. So what is the answer over here? We can see 0 to 1.5 seconds. The graph is straight line, as I say earlier, with a steep positive gradient. That means the velocity is constant and high. After the 1.5 to 6 seconds, the line curves and its gradient gradually decreases over the time. Therefore, the velocity is decreasing. It means some kind of deceleration over here. Okay, this is like this 1.5 they say. Okay, after this it is banned, so it should be a velocity decrease in the velocity. The second question says calculate the average velocity during the time interval 0 to 1.5 seconds. In order to calculate the velocity of this time duration, you need what is the velocity at the time 0? It is 0. And what is the velocity about 1.5 seconds? You can see clearly from the graph, and it is 45 meter. So average velocity means delta x upon delta t. 45 minus 0, 1.5 minus 0, 30 meter per second. So this is question number two. Question number three says, so that The average acceleration between 1.5 second and 4 second is minus 7.2 meter per second square. Here we need to find what is the acceleration over here. But first, this is a graph of displacement versus time. First, we need to find what is the time over, velocity over here, and what is the average velocity over here. Then use those velocities, we can find what is average acceleration. So we know the what is 30 meter per second, t is equal to 1.5 second because we have already done here. Okay, average velocity at this particular 1.5 second. But we don't know what is the value average velocity at t is equal to 4 second. So let's suppose take 2 points before the t 4 second and after the 4 second. You can choose any point. Okay. So first I choose 2 second 74 meter, 6 second and 122 meter. So put these values over here, you will get what is the average velocity at the 4 second. It is 12 meter per second. Now we have to calculate the average acceleration. For that, we have a V2 V1 upon delta t. So 12 minus 30 upon 4 minus 1.5 minus 7.2 meter per second square. This is the exact we need to value, which is asking the question. If you take other than these points, you can also get the same value over here because the acceleration is constant. So, question, this is about question number 3. Now, question number 4 says calculate the average force acting on car between 1.5 seconds to 4 seconds. They given a mass over here, which is 1500 kilogram, and A we have calculated before, which is minus 7.2 meter per second square. In the next unit, you can learn Newton's second law of motion, but we can use here. So remember this equation. If you don't remember, don't bother yourself. We will get more idea on this in our next unit, dynamics. So put this value over here, and you will get the minus value of force. The Newton is the SI unit of force, as we discussed in Unit 1. So if you are not watching Unit 1, please go and watch it. Then you can easily understand what is the basics of physics. So now, why we have a negative value over here? It shows the force is acting on the uh, repel, or I would say it is opposite to the motion. Okay, we will discuss the more precise in the unit 3. Okay, so this is the question number 4. It's about question number 23, and we have a 4 subparts questions of question number 23. 4 says a ball is projected with a horizontal velocity of 1.1 meter per second from the edge point A, the edge of the table. Okay, the ball is going from here. They given us a initial velocity which is horizontal only, and it's going to be at B after some time, and it will cover the distance, I think, 0.43 meter. They given us, and the part of the ball also they describe. Now, question number says A says calculate the time taken for the ball to fall from A to B. Okay, we need to time. As we discussed in our question earlier sessions, that what's how we find t. We have initial velocity in the x direction, 1.1 meter per second, and we also have horizontal distance. So use the basic definition of velocity and make a subject of t because we need to find t over here. So it is x is 0.43 and vx is 1.1, and it will give you answer is 0.3 times second. Question number 2 says use your answer in B1 to determine the height of the table. So you just have to find what is height of the table. So it means h. So We have to use this equation of motion. It is because the A is constant, G is a constant, I would say. Initial velocity of U1, 0. Why? Because the initial velocity is only on the x direction. Okay. So Uy is equal to 0, half gt square, 9.8. And the t is, we have used this over here. And you will get the answer over here. What is the height of the table? 0.75 meter. Now, the ball leaves the table at time t is equal to 0. Okay. For the motion of the ball between A and B, sketch the graph copies 2.37 show the variation with the time t of acceleration of A, vertical component areas V, displacement of the ball from A. Okay, we need to draw the graph. Okay, so here A is constant throughout the motion. G is constant. So you can draw like this. Okay, now if you want to draw Sy versus T means what is the distance versus time graph. So A is the constant of the time, the origin from the source curve upward. Here, why here T square? Because in this graph, it is about Sy proportional to T square. Okay, okay. So it is about the graph of A versus time and the Sy versus time. Now we have a ball of greater mass. If they say mass of the ball is heavy, then what happens? We get the same values or not. So in these situations, we don't have a content of mass. Okay, we didn't bother about the mass of the ball in this equation and also this equation. Okay, so there's a no mention over here the mass. That's why we can do if ball is has a some different mass, the value will be same. State to explain the effect, if any, the increased mass on the time taken from the ball to hold the ground. So, as I say earlier, there's no effect over here, and the vertical acceleration is only on depend on g, not the mass. So that means it also independent. If you ignore the air resistance is negligible. Okay, I hope you understand this today's questions and the solution. So we have remained some problems, so we can continue in our next video. And you have to practice a lot of this question. That's then and then only you can easily understand the concept of the kinematics. So thank you for watching. Subscribe for more physics lectures.